welcome back. Now we will discuss about the dual slope ADC, the second type of ADC which is extensively used in digital relays. The dual slope ADC, it has got its name because it integrates two different ramps. But before going for that, we will see the important components. The important components are a counter is required, a comparator is required, and here an analog integrator is required instead of a DAC. In the earlier case, we have seen that counter and comparator along with them and a DAC was there, right? But here we do employ an analog integrator, most probably an RC type of circuits. So in dual slope type ADC, the integrator generates two different ramps, one with known input voltage and the other with a known reference voltage. Now, since it generates two different ramps, it is called as a dual slope A to D converter. Now, let's see this diagram. I hope you do understand this one. If you carefully see, this is an analog integrator. So this is your input which you are giving. So with the help of a sample and hold circuit, you will be giving your input voltage. This is your analog inputs. And this is your reference voltage, which is given at B. So initially what happens is, your switch will be at S1 condition. So you will allow analog input to pass through this integrator circuit. This is an integrator circuit. Whatever the dotted line I am drawing, this is an analog integrator. Yeah, this is being mentioned here, analog integrator. This dotted line. What happens is, it integrates whatever the value which you are giving here. See, this is an analog input which has been provided here. Now, this voltage, whatever you are getting here, this will be present here. Okay. So now, since it is being present here, this is present at the integrating terminal, right? So what happens is, your output voltage will be negative in nature. So for a fixed duration of time, you will be allowing your input to pass through this integrator circuit. Let us suppose this is my input, V input. Okay. So since it passes through your integrator and it is connected to your inverting terminal, what happens is, I will allow it only for a shorter duration of time. How much duration of time? It is my choice. So let us suppose if I allow it. So this is a constant. Integration of a some constant is, it is Vn into T. Right? Constant integration is T, right? And that too, since I am giving it at the inverting terminal, what I will be getting? I will be getting minus Vn T, which means it is a negative ramp. So what I will be getting? My output will be, with respect to time, my output will be like this. So I will allow it for a fixed duration of time. Let us suppose T1. I will allow it for T1 amount of time. Okay. So my output now is 0. Sorry, my output now is this one. My integrator output, right? Now if you carefully see, this is a comparator now. Now the output of a comparator is 1 as long as V output is greater than 0. And it is 0 when V output is greater than 0. See, now what is my V output? My V output is negative, right? So since it is negative, automatically what happens is, now my output of the comparator will be 1. Since it is 1, what happens? We have already seen this one. What will happen to this clock pulse? The clock pulse now, it will be allowed into this one. So slowly my counter goes on increasing, and after some time what happens is, what I will do is nothing but I will move the switch to B position after some time T1, which is of my own choice. So VR is a reference value. So now VR, I don't know what is VR. Let us suppose VR is something which is less than this value, V input. So what happens is, if it is less than this value, it may take too much amount of time, right? Slowly it will increase, right? So this is a positive slope, right? because this is your minus VR, if you carefully see, right? So it will be you will be getting a positive slope, and slowly this output voltage, it goes on increasing, and at some point it reaches 0. So the output at some point, which was negative due to the integration of this input, now reaches 0 after some time. This is an automatic setter. T1 was of my choice. T2 I will leave it. Up to which time? Till my V output becomes 0. Because the moment V output becomes 0, if it is greater than 0, then automatically this will become, comparator output will become 0, and it won't allow any clock pulses to move into it. Understand? So how many number of clock pulses have entered into this counter? That is your digital equivalents of your analog inputs. Understood? Now, how it is going to work? This I will explain. Let us suppose this is my reference value. Let us suppose. Okay, this is my reference value. Now let us suppose this is my 0, this is my VR, and this is my V input. Let us suppose V input is higher. So automatically what happens if I allow it for some T1 time, right? VR, this is my VR. Let us suppose this is my initial case, right? If I go on increasing this Vn for second case, so automatically what happens is the slope will be higher. So, right. So what happens? I'll take more amount of time. If I take V input is at this peak value, so the slope will be still higher. So this one doesn't change. So its slope remains same, but only this slope is varying because of the magnitude of V input. So the higher the value of V input, then automatically what happens is the time taken, it is going to increase, which means more number of pulses do move into the counter. Understood? So let us suppose if it is lower than V reference, and automatically what happens? Its slope will be very smaller, and you may get it very quickly. This is how. So depending upon the magnitude of input voltage, the number of pulses which enter into the counter, it is going to vary. The higher your input voltage, more number of pulses are going to enter. The lower, lesser number of pulses are going to enter. Understood? So yeah, this is the timing diagram, if you carefully see. This is a negative slope which is being due to your input voltage, and this is due to your reference voltage. Okay, this is your fixed duration. T2 is going to vary depending upon your depending upon the value of this one. T2 is going to vary. The higher Vi, then automatically I'll be getting a higher negative slope. So this T2 may vary, but T1 is going to be fixed. Okay, so the operation which I have already explained, time t is equal to 0, switch S1 is connected to A, sample and hold voltage is applied to analog integrator which integrates VA for a fixed time T1. After that, it is thrown to B where minus VR is connected. This will be integrated and the output starts to move in the positive direction. The moment it reaches 0, gate will be disabled and clock pulses will not enter the circuit. So the number of clock pulses entered is equivalent to the magnitude of input voltage. Once your conversion is done, the reset voltage is arranged to stop the completely. So what are the advantages? Very high accuracy, but the problem is that the conversion takes huge number of time. So relatively slow conversion rates, which limits its application in some digital link devices. Okay, I hope that now you have understood this one. And in the next class, we will see parallel comparator type of ADC, or what we call it as flash type of ADC.